Okay, so in today's video we're going to have a look at using the sine rule. Now in this particular video I'm not going to go over why the sine rule works. I have actually made a video on that, proving the trigonometric rules. So check out that video in the description if you do want to know how and why these work and the proof behind them. But in this video we're just going to focus on actually using it and making sure that you're comfortable answering these sorts of questions. So grab a piece of paper, grab a pen, make some notes. I'm going to get started with this question. So it says find the length of side x and give your answer to 3 significant figures. Now obviously we need to know the sine rule for this, and we're going to talk about how we know that this question would be a sine rule question and how we're going to identify particular questions and know that we're going to use this rule. So the sine rule is a over sine a, and that's little a over sine big A, and that is equal to little b over sine big B, which is also equal to little c over sine big C. Now in any particular question you're only ever going to use two of these. So to be honest I don't actually use the c over sine big C, although it is part of our rule. Obviously looking at that in the video that I've made showing you how this sine rule is created, but for the purpose of this video I'm actually not going to be using that, so I'm just going to be using this a over sine big A is b over sine big B. Now in terms of the question and those letters and what they mean, the little a just represents the sides and the big A represents the angle, okay, or the little letters represent the sides and the big letters represent the angles. Now what we're going to have a look for in a particular triangle is whether we've got pairs of opposites. Now what I mean by that is opposites like this. So opposite the 105 is the 14.6, and opposite the x there, and if I do this in a different colour, we've got the 62. So when we're looking at using the sine rule, we're looking for these pairs of opposites, and without them we can't actually use the sine rule. We have to have these two pairs of opposites. Now obviously one of those is going to be an unknown, and in this case it's the x there, so we've got the one unknown. The rest of them we've either got angles or sides relative to them in terms of the opposites there. Now all we need to do is actually just label this triangle up. So I'm going to get rid of some of this and we're going to label it. Now I'm only going to use the letters A and B purely because I'm not using the c over sine c, and I can label this triangle however I want. So if I just go for this pair of opposites to start with, and let's label those A and big A. So the little a goes with the side down here, so A is the 14.6 and the big A is the 105. Then labelling up the other sides, again I could have done this the other way around, but you're able to choose whatever you like. Now the x is going to be the little b, and the 62 there will be my big B. And as long as you're happy labelling that up there, all we've actually got to now do is plug it into the formula. Now in terms of obviously looking at the sine rule, basically a over sine a, it comes out as 14.6 over sine 105. Okay, I'm going to put the 105 there in a bracket just to help with some calculators. Now, this is the important part here really, and that is that 14.6 divided by sine 105 is always going to be equal to the other pair of opposites when I plug those numbers in. So it's going to be equal to whatever the x value is divided by sine 62. Again, I've gone over the explanation as to why that happens in the video that I've mentioned in the description, but all we're going to have to do now is just make sure that these balance. So we've got 14.6 over sine 105, and that has to be equal to x, which is my little b, over sine 62. And again I'm going to put that into a bracket. And again, obviously, this is a calculator topic, so you will need your calculator to hand for these questions. So we've got 14.6 over sine 105 is equal to sine x over sine 62. Now I can type in 14.6 over sine 105 if I want. I can type that into the calculator. And if I type that in, 14.6 on the top and sine 105 on the bottom, and I press equals, I get quite a nasty decimal. It's 15.11503223. Now basically we need to find the value of x that's going to make that equal. Okay, and we could obviously do lots of trial and error there. You could keep plugging in numbers until you get that same value, so you could write it down and just keep on going. Or we can save a bit of time just by rearranging this equation. So if I want to rearrange the equation just so it says that it equals x, so I can plug it all in one go, I need to get rid of this sine 62 on the bottom. And I can do that quite easily. I can just times both sides by sine 62. There's two ways you can do that. Obviously we could work out this part here, which comes out as 15.115 and a few more decimals. I'll just put a little dot dot dot. Okay, and then we could times it by sine 62 to remove that divide by sine 62 over there. Or I could just remove it all in one step and type it all in one go. So it's completely up to you. Either work out what's on the left there, 15.115, and then times it by sine 62, or as what I'm going to do here, I'm just going to write it all in one go. I'm going to times this sine 62, and it's going to put it up here on the numerator, remembering you're timesing fractions there. If you times a fraction by anything, it affects the numerator there. So if I do that, we get 14.6 multiplied by sine 62. I don't have to put the multiply in, I can just put sine 62. So 14.6 sine 62, all divided by sine 105 equals x. And obviously x is what we're looking for there. So all I've got to do is type that in. So press your fraction button. If you don't have a fraction button, obviously type in what's on the top, press equals, and then divide by what's on the bottom. But hopefully you've got your fraction button. So 14.6 sine 62, don't forget to close your brackets, and sine 105 on the bottom, and again closing the bracket. And if I press equals there, I'm going to write that over to the left. We get x equals 13.3457. I'm not going to write down all of the decimals here because it does keep on going, but it wants it to 3 significant figures there. So I just need to obviously round this question. So that second 3 is my third significant figure. So my final answer will be 13.3. And off we get my units, centimetres. And there's our final answer, 13.3 centimetres. Okay, so lots of things to be thinking about there, obviously, when we're looking at the sine rule. We're looking at these pairs of opposites. Without them, we can't use it. We won't have our a's and b's. We won't actually be able to plug the values into our formula. And then just thinking about, obviously, writing the formula down and rearranging it. Or, obviously, thinking about the other method there of typing it in and then timesing by that denominator. Okay, so we're going to have a look at another question. I'm going to do this next one a little bit quicker. We're just going to apply the same method that we've applied to this question. Okay, so here it is. So this question says, find the length of side x and give your answer correct to 3 significant figures. So again, let's have a look. We've got a pair of opposites here, so that's okay, we can use that. And we've got a pair of opposites here, again, one of them being the unknown there, the x on the right. Okay, so we can definitely use the sine rule. So we just write the sine rule down, so a over sine a equals b over sine b. There we go, and obviously thinking about normal trigonometry there when we did some SOHCAHTOA, obviously linked in the description in some of the previous videos. The big letter goes with the sine, just like when we were using sin, cos, tan, we always put the angle with that, okay? So obviously just remembering your big letters go with that. So we can label it up, we don't have to label it up, but it does help just to visualise it. So A and big A, and then we've got little b here, and big B, and again you could label that however you like, it doesn't matter which one's A and B, they're all going to go into the formula in the same way. Okay, just obviously what is important is making sure the opposites are matching with the A's and B's. So let's plug this all in. We get 13 over sine 100. There we go, and that's got to be equal to x over sine 38. There we go. So again, you can type in what's on the left there, 13 over sine 100, and multiply it by that denominator, or we can just rearrange it all in one go and write it out and type it in. So times both sides by sine 38, we get 13 sine 38 over sine 100, and again now we just need to type that in and we've got the answer finished. There we are, just about write that in there. So let's type that in. So fraction button, 13 sine 38 all over sine 100, close the brackets, press equals, and again we get an answer here of 8.127, a few more decimals, but it wants it to 3 significant figures, so I don't need to go any further. And if I round that to 3 significant figures, chop it after the 2, we get 8.13 when it rounds up there, and again that's centimetres. And there we go, there's our final answer using the sine rule. Now very, very quickly before we have a go, just have a look at a quick question where we may or may not be able to use the sine rule, but let's just have a look at that one quickly before we move on. Okay, so this question here says find the length of AC, why can we not use the sine rule? Okay, so this obviously is not like an exam style question, but it is just thinking about if you were faced with this question and you were sitting there and trying to think, oh, you know, can I use the sine rule? We're going to have a look at why we can't. So opposite the 67 is the length AC, so obviously knowing how to read these lengths, so AC is over here, if we call that X, that's over there. So obviously we have a pair of opposites here, we've got 67 and the x. So we've got one pair of opposites, but if you have a look at the others, look, opposite the 28.3, we don't have the angle, so we can't use that pair of opposites. And then opposite the 11.7, we don't have that angle, So we don't have another pair of opposites. So in this sort of question here, we've only got one pair of opposites. Now in the next video, we're going to have a look at the rule that we use, obviously, to find missing lengths if we don't have these pairs of opposites. But for now, just thinking about the sine rule and how you identify a question where you're actually going to be using the sine rule, and this is not one of them. Okay, so just obviously in the practice questions that you're going to have a go at, make sure you identify these two pairs of opposites before you go ahead and just start sticking numbers in the sine rule. So label them all up and keep it all nice and tidy. Okay, so here's two questions for you to have a go at. Okay, so here's two questions, so pause the video there, have a go, and we'll go over the answers in a sec. Okay, so the first one says find the length of AB, so AB is over here, and then we're just going to label that up, so let's just call this one A, and you might have done this in a slightly different way with your A's and B's, but we're going to get the same answer either way, and let's call this one B. Now, obviously something else to be thinking about on these that I didn't really mention on the previous one is that sometimes they will give you letters on the outside of the triangles. Now, I personally, and if I just get rid of how I've labelled this here, I personally always just scribble them out. Obviously we need it to know what side we're looking for, but I don't want it to confuse me in terms of my labelling there, so I'm going to scribble it out. This is now my big A, and this is now my big B. Okay, so if that threw you at all, obviously just cross them out as soon as you need to start using the sine rule, and you allocate the letters however you like. So plugging these numbers in, I'm not going to write the formula out, but we've got 12 over sine 55. Again, depending on which order you've done this, might depend on which order you write this, and that'll be equal to x over sine 20. Okay, there we go. X is opposite my 20 there, obviously just drawing in your opposite lines if you want to, and then these are my other pair of opposites here. So again, plugging that all into the calculator, look, we just need to times this sine 20 over to the 12. So when I type that into the calculator, I've got 12 sine 20, and on the bottom I've got sine 55. Press equals, and we get 5.0103. So 0 after the 1 there means it's going to stay as a 1, it's not going to change. So 5.01 centimetres, and that's our final answer for that question there. Let's just finish that off. Okay, I'm doing minimal working out on the screen here just to save some space. Moving on to the next one, we've got a pair of opposites here. So let's again forget about the letters on the outside, I'll call that A and A. And then we're looking for the length BC, which is over here, and that's opposite the 42. So there we go, we've got big B and little b over here. Plugging those values into the sine rule then, we've got 5 over sine 53. And that is equal to x over sine 42. And again, just removing that denominator on the right there, we'll put it up the top. So in my calculator, I'm going to type in fraction button, and then on the top 5 sine 42, and on the bottom we've got sine 53. There we go. Press equals, and again we've got our answer here. So the answer comes out as 4.189 and a few more decimals. Now I've written it all down this time because obviously after the 8 there it does round up, so our final answer is 4.19, and again that's centimetres. Oh, actually no, it's not, it's metres. There we go, always a good reason to make sure you do have a look at the units there. 4.19 metres, and there we go, there's the final answer for that question. There we go. Right, so moving on to the next part of this topic now, we're going to have a look at finding angles using the sine rule. Okay, so this question says, work out the size of angle x, give your answer correct to 3 significant figures. Now again, just thinking about the question, look, I know we're finding an angle this time, but look, we have got this pair of opposites here, and also we've got a pair of opposites over here. So if I just label this up just like before, we've got A and big A, and B and big B. Okay, but if I was to plug these into my sine rule, formula like we did before, we'd have 6.7 over sine 95. And that would be equal to 5.4 this time over sine x. Now you can actually use the sine rule like this, and obviously we could actually do quite a bit of rearranging here to get that x on its own. But obviously what we want to do is we want to get this part on its own, this sine x part. And if we times that to the other side now, it's going to go onto the top of the fraction here, and it's not really going to be on its own in that first step. So there is a really quick step with the sine rule, obviously just to help you with the rearrangement here, and that's just to flip them over. Now the reason we can just flip them over, if we think about a little bit of logic here, if we have two fractions that are equal to each other, let's just pick something easy, like 1/2 is equal to 2/4. Now that is a correct statement there. 1/2 is equal to 2/4, and if we flip them over, we get 2 over 1 is equal to 4 over 2. 2 divided by 1 is 2, 4 divided by 2 is 2, and 2 equals 2 is again a correct statement. So you are able to flip fractions over like this when we're equating them to each other. Obviously they equal different things there, but the statement is still correct. They still have to equal each other. So when we're looking for angles, all we're going to do is we're going to flip the fractions over and use the sine rule upside down, so to speak. So we've got sine A over little a is going to equal sine big B over little b. And you're going to see now when we put the numbers in, we get to rearrange this in one step just like we did before. So if we plug all these values in, I've got sine 95 as my big A, and that's over the opposite there, which is 6.7, and that is equal to sine x. I'll put the x in a bracket just like I do with the normal angles, and that is opposite the 5.4. Okay, so now we are actually able to eliminate or isolate the sine x on its own by getting rid of this 5.4 on the bottom. This divide by 5.4, again just timesing both sides by 5.4. So when I times this up, and again I'm going to write it in the same way as I did before. So when I times it up to the numerator, look, I'm going to write it just at the start here, and I'll write it down to start with. So that would give me 5.4 sine 95, and that's over 6.7. And that now equals sine x. There we go. So not got the x on its own, but it does equal sine x. Now if I type all of that into the calculator, let's see what we get. So let's type all of that in. So on the top I've got 5.4 sine 95, and on the bottom I've got 6.7. And if I press equals, let's see what we get. So I get quite a long decimal. So we've got 0.802903, and you know, we're not going to write it all down. I'm just going to leave it on my calculator screen for the moment. But that is what all of this little bit on the left here equals when I type it all in. Now obviously that equals sine x. It doesn't equal x, it's not our answer. So that equals sine x, and I'll put the x back in a bracket. Now, this should hopefully link through to normal trigonometry when we were looking at SOHCAHTOA. If you want to separate these two parts out and obviously figure out what x is, we can do the inverse of sine. So I can press that shift sine button and it will do the inverse, and that will help me just to figure out what x actually is and not sine x. So obviously thinking about your normal trigonometry there, press shift and then sine, and you get this sine minus 1, your inverse sine. Okay, and we're going to do the inverse of this value here that's on your calculator. So that'll be the inverse sine. I'm just going to press the answer button. So I'm just going to write ANS here rather than that decimal. But obviously that is just that decimal there that I'm writing in the bracket. You can feel free to write it all in if you want, but it seems like an unnecessary step when we can use our calculator a bit more efficiently here. So shift sine, ANS, which is next to the equals button, close the bracket and press equals, and it gives us the size of the angle, which is 53.408 and a few more decimals, but again it wants me to round it to 3 significant figures, so I can chop it after the 4 and we get 53.5. There we go, and this is about degrees this time, so degrees, and there's our final answer. It's obviously a very similar process in terms of the way we use the formula, but we have that final step there of using the inverse of sine to find out the size of the angle. Okay, just like with normal trigonometry when we're looking at right angled triangles, we still use that inverse of sine when we're looking for an angle. Okay, so that is how you use the sine rule the other way around when we're looking at an angle. I'm not going to go over any more questions there, so that's your question on that, and now you're going to have a go at a couple. So I've got 2 questions for you to have a go at, and here they are. Okay, so there's 2 questions there looking for angles using the sine rule. So obviously label up your triangles, identify your opposites, plug it into your formula, and don't forget to use your inverse sign at the end when you're finding the size of the angle. Okay, so pause the video there, and we'll go over the answer in a sec. So angle BAC. Now angle BAC is up here, so this is the angle that we're looking for. That B is not very clear there, but there we go. So it says give your answer to 3 significant figures. Now let's have a look. So we've got our pairs of opposites here, and we've got our pairs of opposites over here. So I'm going to call this A and this little a, and we'll have B and little b there. Okay, so labelling this up, and it doesn't matter if obviously if you've labelled it differently again, but we've got sine 43 over the opposite to that, which is 14, and that is equal to sine x over the opposite to that, which is 20. And then again we've just got to rearrange this, so let's get the 20 up to the top. So we have 20 sine 43, 20 sine 43 over 14, and that equals sine x. Now if I type that all in, let's see what we've got. So fraction button, we've got 20 sine 43, and on the bottom 14. Press equals, and we get 0.9742. Obviously we're going to do the inverse of sine again, so I'm going to do sine minus 1, shift sine, and then in there we've got 0.97428 and a few more decimals, and this is why I'm going to use the answer button because I don't really want to be typing all of those numbers in. And let's see what we get for that. So shift sign, answer, close the bracket, and it comes out as 76.9779 and a few more decimals, but again it wants it to 3 significant figures, so 76.9, but the 9 rounds up, so that obviously rounds my number up here, so you've got to be careful with this one. So that obviously rounds it up to 77, and that would be a 0.0 at the end there, so 77.0 degrees. Obviously it does say 3 significant figures, so you do have to highlight that 0 at the end there just to incorporate that third significant figure. So 77.0 degrees is our final answer. Right, okay, so I'm going to do this second one a little bit faster. So here's my first pair of opposites. We've got A and little a, and we've got another pair of opposites here. We've got B and little b. There we go. So if I plug these into my formula, let's have a look. We've got sine A, which is sine x. So we've got sine x over 10, opposite to that, and that equals sine 60 over, opposite to that is 15. Now if we rearrange that, we've got 10 times sine 60 on the right, so I'm just going to move that with a little arrow here, and I'm just going to type that straight in. So we've got sine x equals, and on my calculator, 10 sine 60, and on the bottom we've got 15, and that comes out as 0.5773, a few more decimals, so 0.5773. I'm not going to round it, I'm just going to put a few dots there, and then I just need to do the inverse, so sine minus 1, and I'm just going to put answer here. There you are, sine minus 1 of the answer. So shift sign, answer, close the bracket, and that equals 35.264. It wants it to 3 significant figures, so it's 26, so the 2 rounds up to a 3, so 35.3 degrees. There we go, and I'll just highlight that as our final answer there, 35.3. Right, okay, so before we finish, I've got a few different types of questions for you to have a look at, so let's have a look at one of those. Right, so this question here says, calculate the length of DC. Now there's 2 triangles here put together. We've got a triangle on the left there, ABD, and we've got a triangle on the right there, that right angle triangle BDC. Now obviously if we've got a right angle triangle involved, we could have to use some Pythagoras or some Tutor in this question, but we'll just have a look and see what we can find. So we're trying to find the length of DC, which is this length just here. Now at the moment we've not got enough information to sort of move around the triangle. The right one there we've only got an angle, no lengths, and the left one there we've actually only got 1 angle and 1 length, so we're going to have a look and see if we can find anything else. Now straight away we can work out this angle just here, because that's on a straight line with the 54. So if I do 180 take away 54, that gives me the angle 126. There we go, so 126 degrees. Now we still don't have enough information to use the sine rule because we haven't even got 1 pair of opposites yet. So actually we're going to have to look at finding something else. Now again, we've got angles in a triangle, so we can find this one just up here. So 28 plus 126 adds up to 154, and if we take away 180, take that away from 180, we get 26 up for this angle just here. I'm just showing my working out for that. I did 180, take away 154. There we go, 26. Now let's have a look. Do we have a pair of opposites? So opposite the 25, we've got that 26 degrees. Okay, so if we're going to try and find this side here, we just need to have a look for a pair of opposites now to see if we can start moving into that triangle on the right. So opposite the 25, we've got that 26. So let's call 26 big A and the little 25 little a. And then obviously another pair of opposites we're looking at is the one where the 28 is, so big B, and the side we're going to find here, little b. So we're trying to find a side length, not an angle. So we're going to use obviously the first formula we were looking at, which was a over sine A. So little a is 25. So a over sine 26, that angle up in the top that we've worked out, has to be equal to x, the length that we're looking for. Obviously not the length in the final that I've labelled on the right, but the question mark there. So x over sine 28. There we go, and let's rearrange that to get our value of x there. So 25 sine 28 over sine 26. That's quite nice, that's going to give us our answer straight away. So 25 sine 28 all over sine 26. Press equals, and I get the value 26.77 and a few more decimals. It doesn't say how to round it in this question, so I'm just going to round it appropriately. We're just having a look at actually how to approach this question, but we've got 26.77 for this length just here, and I'm going to leave the answer on my calculator, so 26.77. Now looking at that triangle on the right now, it's a right angled triangle. We've not got enough lengths to think about using Pythagoras, so we're going to have to think about another way. So we're going to have to look at using some Tutor here. So obviously thinking about Tutor as well. So opposite the 54 is the side we're looking for, so that's our opposite side, and we've just worked out the hypotenuse of that triangle. So O and H is in our sine formula, thinking obviously about your Tutor as well here. So we're trying to find a side length, we're trying to find the opposite, so we're going to times S times H. So we're going to do H, which is 26.77, multiplied by sine 54. There we go, using a bit of Tutor, and let's type that in. I've already got the answer for the 26.77, so I'm just going to times that straight away by sine 54, and it gives me the answer 21.66. I'm going to keep it to 2 decimal places, and it is all about meters. There we go, so 21.66 meters, and there's the final answer to that question. Obviously just rounding it however we would be asked to in a particular question. So something a little bit different there, thinking about obviously your Pythagoras or Tutor and whether that might be involved in a question, but also thinking on the left there about some missing angles in the triangle or on a straight line to actually get those angles that you need so that you can get your pair of opposites. Now I've got one last question for you to have a go at, which is a similar sort of style to this question, probably a little bit easier, but a similar sort of style question where you're going to have to use the sine rule and potentially something else, and thinking about how you're going to approach that. So here it is. Okay, so this question says calculate the length of x and give your answer to correct to 1 decimal place. So have a go at this question, pause the video there, and we'll go over the answer in a sec. Okay, so the question on here, we've got a right angled triangle on the right and a non-right angled triangle on the left. So we're going to think about how we can use the sine rule to work out that length of x there, but just looking at that triangle, we've not got a pair of opposites at the moment. Now what we do have is, I'm just thinking about just some of the basics here, we can work out this angle here, because at the moment we've got 40 and 65, and if we add those up, that's 105. So to work out this angle here, we could do 180, take away 105, and it will give us 75 degrees, so 75 degrees there. There we are, and that's obviously opposite the side that we're looking for, so that's going to be helpful. And then potentially if we can work out this side, that's going to be opposite this 40, so we've already thinking about how we're going to get a pair of opposites for that triangle. Now that triangle on the right, we've got 2 lengths, we've got 13 and 5, we've got no angles involved, so we can't use Tutor, but we can use Pythagoras. So we're trying to find one of the shorter sides, so we can do 13 squared, take away 5 squared, and we'll work that out and square root our answer. So it's 169 take away 25, which is 144. Quite nice, because that square roots to a nice whole number. So the square root of 144 is 12. So that length there is 12, opposite the 40 degrees. So if we type this all again back into the sine rule, let's have a look. We've got 12 over sine 40. And that's equal to x that we're looking for over sine 75, the angle there that we found that's opposite, so sine 75. And again, if we rearrange that, so times that 75 up to the top here, and we get 12 sine 75 divided by sine 40. And I can type that all straight into the calculator, so 12 sine 75 divided by sine 40. There we go, and that equals 18.03 and a few more decimals. It wants it to 1 decimal place, so that would be 18.0. Another one of these sort of strange questions where we have to incorporate the 0. So if I write that all over here, we've got 18.0, and that's all about centimetres. There we go, so there's our final answer, making sure that's to 1 decimal place. There we are, and that is the end of using the sine rule. So hopefully that was helpful. If it was useful, please like, please comment, please subscribe, and I'll see you for the next video where we're going to be looking at the cosine rule.